I'm delighted to introduce Dr. James Grieve. He's a Senior Director, Quantum Communications at TII, Technology Innovation Institute. He's going to talk about quantum secure communications. So James, please come to the stage. Thank you. Hey, nice to see you.
Okay, thank you very much. I'm not sure I can follow that though, Jay. That was a pretty strong... Okay, so this is going to seem way lower key than that, right? But thank you very much for the introduction, and I will try and make my way through these slides. So yeah, I'm going to talk about quantum secure communications. My position at TII is part of the Quantum Research Center, so I'm not going to talk about post-quantum encryption. I'm going to talk about QKD primarily. That's our area. And I want to talk a bit about sort of generally what we've been doing in QKD, just in case this message hasn't reached everyone yet. But I also wanted to try and make it at least a little bit about maritime in recognition of the event itself, right? So there'll be a kind of discontinuity halfway through where I suddenly start talking about, anyway, hopefully it won't be too abrupt, right? But okay, I'll start out by throwing this up, right? So what we've been up to for the last 5 years in Abu Dhabi is developing some domestic capability in these areas, right? So this is within my team only. We have a larger quantum center that works on computing and sensing. I think we had a talk yesterday from my colleagues in sensing, right? So this is specific to the communication side, but we have entanglement-based QKD. We have something we call last mile QKD. This is a sort of cost-optimized approach. We have QRNGs that I won't talk about at all. And but I have one in my pocket if somebody would like to talk about it later. And we also have a ground station for doing space QKD, right? So this is the rough prospectus. And I think I'd like to say that today we can build quantum networks, right? So QKD networks in Abu Dhabi are a reality. We can do this, right? We can make sort of rings and stars, and we have equipment to support this, right? So available right now, we have an entanglement-based QKD solution. There's 2 of those running in Abu Dhabi right now in various places. I'll talk about one of them later. So that's stable, that works. You can buy that today from my colleagues in Venture One. We also have last mile QKD, which is not ready yet. That'll be ready. It works in the lab, right? So that should be working outside the lab sometime next year. And we're going to aim to have something which you can buy or at least trial, maybe the start of H2, right? So that's coming soon. And that will be a kind of cost-optimized approach to extend this quantum guarantee further out into the kind of leaf nodes of networks, right? Maybe not quantum to the home, right? But I'd like to think quantum to the SME or something, right? This is the vision, yeah? Right. A little bit about the entanglement-based system, because that's the one that we can sell people right now, right? So we have a system based on distribution of polarization entanglement. So there's a kind of server device. That's the large blue device. We've since made all the devices black, right? So they look much less jarring now, right? But anyway, big purple device is an entanglement server that connects pairs of devices with entangled photons. You can combine that with a switch, so you can connect different pairs of devices. So you can kind of build a larger scale network by time sharing that resource across different nodes. And we have receiver devices. Those are the white devices, right? So that's where the keys are generated, right? This works over optical fiber. It's an O-band technology in the picture here, which is range limited to about 40 kilometers. I'm aware that 40 kilometers is not going to blow anyone's mind, right? So we have a C-band variant that achieves more like 70 kilometers, right? And we have a long-range variant that should be coming online maybe towards the end of next year, which I'm optimistic we can get well past 100K on that one, right? But yeah, all of this exists. We do key provisioning, so just like everybody else's QKD devices, you can upload the keys from these machines onto, for example, in this photograph, Fortinet devices, but also like Cisco and Juniper and Adtran and Ciena and probably all the other ones as well, right? And we have, of course, a full security analysis, which I think is obligatory for QKD, but I mention it just in case, right? So this is, a sort of respectable, academically endorsed system, yeah? And it's been tested, right? So we have this resource. We're based in Masdar City, which is a sort of 20-minute drive that way, I think. And we have a private fiber loop in Masdar City, which we've had operational since 2022. And this is about 10 kilometers long. It's a loop-back configuration, so it starts and stops in my lab. And we have 48 fibers that are just dedicated for our use, right? So this is quite nice. What this means is we were able to test these devices as we built them in a kind of live environment. So by the time we have something ready to take out of the lab, I'm 100% certain it'll work in the wild because we've tested it, right, in this configuration, right? So that's a nice thing to have. We can also configure this in, not necessarily in parallel, but in series, right? And so you can run around the loop many, many times. And I think in principle we can make about a 450 kilometer range, which we haven't done yet because QKD will not work over that range. But in principle we can test long range variants like that. So it's nice to have that resource, and it gives us the reassurance that these systems actually work, right? Even before we put them in a Pelican case, right? Okay, I should mention this briefly. This is a most recent activity we had, and this is one of the networks that's running in Abu Dhabi. So we have I'm not sure what the official name is, right? But it's something like the ADGM Quantum Network. So for those who aren't based in Abu Dhabi, ADGM is the Abu Dhabi Global Markets. It's a kind of financial authority regulator. They have they're sort of the entity which registers companies on Al Maria Island and now also Al Reem Island. So they have a kind of ecosystem of companies that are registered with them as they are the regulator for those companies. And they have a kind of campus, or I'm not sure what they call it internally, but they have about 5 buildings on Al Maria Island, and there's a picture of them down here. And so we've connected 3 of those buildings using fibers, the internal infrastructure in the sites, and we have an entangled source that provisions keys across these 3 points. And the goal is to try to onboard companies in the fintech or financial services or banking sectors or finance adjacent stuff, right? And to try and explore use cases of QKD. So I'm not a banker or a finance person at all, so I don't presume to know what these use cases might be. I have some ideas, right? But they're naive, right? So I don't want to have naive ideas. I want to talk to the actual finance sector and get some properly qualified opinions. So if anyone would like to learn more, there is a QR code up here. It's on the next slide as well, I think. And that will take you to some kind of sign-up page where you can tell me who you are, and then we'll contact you and have a conversation, right? So that's the vision there, right? And there's just an example of network metrics, right? So in terms of how the system performs, I apologize for the graphs, right? But I think it's kind of interesting, right? So on the top layer, you can see this is a time-shared network, right? So not all 3 nodes are generating key all the time, right? And in fact, on a network like this, you shouldn't think so much about nodes, but about connections, right? So imagine a graph. We're not interested in the vertices. We're interested in the actual, sorry, not the nodes, but we are interested in the vertices, right? So each pair of nodes is one line on this graph, and that's the time axis. So you can see that different nodes are kind of, different pairs of nodes are activated at different times. And you have an opportunity here to play with scheduling and play with key provisioning. And in this particular case, we were trying to equalize the network, right? So we wanted every pair of devices to have about the same amount of key. And so you can see that the middle pair was obviously doing quite well, and the bottom pair was not doing very well, lower rate. And so what happened is after some time, we just stopped connecting the middle pair, right? And this illustrates, I think, that how QKD keys are actually used and consumed is via a kind of buffering mechanism. So you don't need these things to be constantly generating key all the time. They generate key for a period of time, feed it into a buffer, and then you start to consume the buffer, right? And then you have to periodically swap the buffer up. But this is the sort of practical reality of QKD systems. And it also leads into this kind of question of how much key rate do you really need. So I know there are companies out there that are selling, I think there is now a megabit QKD solution on the market. You know, I'm not going to say you don't need a megabit solution. I'm going to say most of you don't need a megabit solution. There will be specific use cases where that's important, right? But in general, a 10 gigabit IPsec tunnel will consume about 2.1 bits per second of key, right? And that's if you rekey the thing every 2 minutes, which is the minimum refresh interval for most of the commercial hardware that implements this stuff, right? So if you're generating, say, 30 or 40 bits a second, you can support 2 or 3 IPsec tunnels with pretty healthy margin for your buffer, right? So this is the kind of thing we're working with, right? And so this also is nice for an entanglement-based system because of the nature of the QKD system. I don't want to say it's different from the prepare and measure schemes that are sort of on the market at the moment. And it is intrinsically slightly lower rates. That's one of the compromises you have to accept if you want these kind of rich networks. Speaking of rich networks, I drew this yesterday, so I apologize if it's not super clear, right? But what I wanted to show here was the kind of network complexity that you can build up if you have these kind of shared entanglement resources, right? So I have a QKD layer, and in this picture, the Pac-Man ghost is the entangled photon source, right? Ghosts because Einstein called it spooky, anyway. And then the Pac-Man is the receiver because he's eating the photons, right? So I have 3 receivers and 1 source and a switch, and that's just a switch diagram because I ran out of metaphors. And that's physically what's been built. So you see there's a source and a receiver co-located, and then there are 2 distant receivers in other buildings. And that's what the kind of physical layer looks like. And actually, even the classical connections look like that on it. That's where the fibers run, right? But the top layer is what the user sees. And what they see here is a fully connected graph. So even though, physically speaking, the data traveling between the Hub 71 site and the ADGM Academy site, that data physically passes through the building in the middle, it's not decrypted there, right? Because there's a direct connection. So this is what you would call a fully connected key graph. Every pair of users is independently connected with no trusted relay or anything like that. And we think this has specific use cases that are quite interesting for finance, right? And you need minimum of 3 nodes to pull this off. If you have 2 nodes, then there is only 1 vertex, right? So this is, we think, very interesting and unusual, right? I'm not going to say it's unique, but it's unusual. So I think that'll be fun over the coming months to see what we can do with that, right? Okay, but then I wanted to immediately switch to the maritime sector, right? Like I said, it was going to be a jarring transition. So there are really interesting signs. I know this is the first quantum maritime event, right? But there are some baby steps and things going on, right? So I picked two here. We have this Abu Dhabi Ports trial that I believe was presented yesterday. That's going on right now with my friends from ID Quantique. And there is also this quite famous QKD trial with a company called QBER, the Port of Rotterdam, that's been running for a while. And that's quite interesting. So I stole from their website this picture. So it's a pretty generic. I guess there's a hacker down here, and there's a couple of guys talking via a node in the middle. But I think there's a ton of interesting kind of internal use cases within a port, right? So I understand that some of the stuff these guys are doing is securing a sensor network. And I said, I had the chance to talk to these guys a few months ago, and someone from the Port of Rotterdam was there, and I said, all right, so you have a sensor network? He said, yeah, water levels, this kind of thing. We need to know if we need to move ships out of an area of the port, otherwise they get stuck there and it's a disaster. And sometimes the sensor network returns bad data or whatever, and then we shut down that bit of the port, and it costs us millions, even for an hour or two. And I said, don't you send the guy to check? I mean, right, like ground truth, you're in a port, it's not that big, right? You have bicycles and stuff. And he went, no, we just shut it down. It's a protocol, man. So, okay, they care about the integrity of these networks, and they care about the integrity of data traveling around the port. And this means if you wanted to mess with the Port of Rotterdam, you wouldn't have to do anything particularly elaborate. You just hack into the network and, create a file somewhere, and then have to shut down part of the port, right? So this is the kind of protocols they have in place, and that's why the level of security that QKD can offer you is maybe warranted in this context, which is pretty interesting, I think, right? They also have a use case they told me about, which was to do with connecting together customs facilities. And this is more traditional QKD grounds, right? Because inside these containers, you have stuff, right? Material in the containers, the contents of the containers is private, it's supposed to remain private. You have to disclose it to the customs guys. They have the duty to not disclose that to third parties, right? So you have a requirement of confidentiality. It's potentially quite a long duration requirement, right? You're not supposed to leak information next year or the year after or something. So this store now, decrypt later scenario is relevant, right? And that seemed very interesting to me. But I also found on the website that I took this picture from, this picture, which confused me a bit because now we're in space or something, right? And there's no explanation on this website at all for why they put this picture here. But I have an idea, right? So my thinking here is, ports are intrinsically delocalized global phenomena, right? There is no point in having a port in Abu Dhabi unless someone else has a port too, because otherwise you just send stuff into the ocean and it doesn't go anywhere, right? It just comes back, I guess, right? So this makes it about, this is one of the reasons why I like communication as a field, right? Because it's intrinsically collaborative. You have to communicate with somebody, right? So ports need to send ships to other ports, right? I guess, right? Military context, maybe you can just do a loop and come back, right? But apart from that, we're talking shipping and stuff. And so I think there probably are some very interesting use cases as yet unexplored, I think, in terms of connecting different ports, right? So what if you have some information about manifests that are coming from Abu Dhabi port and some ship is heading off to, Singapore, right? And you need to get that information to Singapore privately. This kind of thing is potentially another interesting use case we can look at, right? And this gives me an opportunity to see against the other thing we do here, which is satellite QKD, right? So these very long-range networks, like between different ports, would require you to bridge, thousands and thousands of kilometers of distance. And although you can do this on the ground using what are called trusted nodes, it's a totally insane proposition. I don't recommend it, okay? Like realistically, trusted node networks, they stop at national borders, right? You can't really do them across multiple jurisdictions. The trust network and the stories you tell yourself about why you trust these nodes just fall apart completely. But you can do it with a satellite, right? So you need one satellite in what's called a traveling trusted node configuration, which is in the diagram here. So if you bear with me, the satellite flies over station A, which maybe is my station here in Abu Dhabi, right? And it does a key exchange. So the satellite does QKD with the ground station, creating a key pair that we call KA, right? Later, maybe next week, maybe tomorrow, I don't know, it flies over another ground station that's in, say, Singapore. And it happens not to be cloudy that day, so it's able to do QKD with the Singapore ground station, and it creates a key pair called KB. So far, so good. But the satellite hasn't really got any meaningful secret information to share with these guys. They would like to talk to each other, right? So what happens is the satellite broadcasts a parity announcement, right? So that's technical jargon, but you can think of it as basically encrypting key A with key B, which is the same as encrypting key B with key A. It's a one-time pad encryption of the two keys. And that means if you know one of the keys, you can calculate the other key. And no one else can, right? It's information theoretic secure. And this is what we would call a classical key swap, right? But it's a legal move in QKD, right? That's how trusted node networks are built. And so this would basically be a 3-node trusted node network with the middle node flying around in low Earth orbit, right? We've extended the concept a little bit. We have this archive paper if people want to go and look at that. This is the idea of using a diverse community of satellites to reduce your trust in any one satellite. But this is the sort of near-term satellite QKD paradigm. To support this, we have a facility here in Abu Dhabi, I mentioned earlier. This is, I think the QR code on this screen will take you to a Google Maps location. And this is in Al Wathba, which is just outside the city. We built this structure. There's an 80-centimeter telescope inside. You can see the picture on Google Earth. I believe a quite clever decision was to place the logo on the secondary plinth, so you can see it from space. Pretty cool. But it's a sort of not very built-up environment. And like I said, inside there is an 80-centimeter tracking telescope. These are pretty heavy devices in every sense of the word, right? But this is what you need to do to track a satellite that's going to appear over the horizon, fly overhead in about 3 minutes, and then vanish, right? So you've got 3 minutes to do as much QKD as possible. So this justifies a large, serious instrument, such as this one. And where we placed it is kind of interesting. So I'm aware it's quite far away from. Does the laser work on this thing? It does, but it doesn't work on the screen. Anyway, Abu Dhabi port is probably... But we placed it there for compromise reasons, right? So in order for the technology to work properly, this satellite QKD stuff is a single photon technology. So I need to be able to detect one particle of light that came from the satellite. And all light particles kind of look similar, right? So even if I spectrally filter and whatever, it's very important to have low background light levels. And I have a sort of luminosity map of Abu Dhabi. It was super terrible. I didn't enjoy showing people it. And then this absolutely fantastic photograph of Abu Dhabi at night was taken by Koichi on the International Space Station in January 2023. I believe that Abu Dhabi hasn't changed too much since then, right? So that's probably still approximately valid. And if you transform that onto this Google Map thing and stretch it and pull it around a little bit, you can get the main features to line up, and it's really enjoyable, right? Like zooming in on this map and looking around is really fun if you live here. But you see our location is just outside of all this kind of light pollution that's going on, right? So it's a nice compromise there. The technology should work. It's dark enough, right? Can you guys see there's like a kind of white blob just top right from our side? That's the Sheikh Zayed Heritage Festival. So while that's running, no one's doing QKD, I'm afraid. They have lasers they fire around and stuff. It's a disaster. But they switch it all off at like midnight. So we get the hours after midnight in which we can do QKD. And critically, this is close enough to Abu Dhabi's population centers that we can do a QKD link on fiber between that side and most of this place, right? So we currently have plans. We have an agreement in place with the UAE Space Agency to connect that site back to Mazda with fiber. And then we'll be able to do a sort of classical key swap between the ground station and various sites. And we should be able to relay key material from the ground station to end users, right? And that's why we didn't place it in the middle of Fujairah or way out in the desert in Al Khat or something, right? Because there's no use for the thing out there, right? So that's a fun concept, right? Where to place these things. Okay, so speaking of this ADQOGS, the acronym we have for the site, it's intrinsically collaborative, right? So we have many partners. If one of my partners is here and your logo is not on the screen, I apologize. This is as up to date as I could get it, right? So some of these guys are making QKD satellites. Some are doing key management and so on, right? But we're lined up now. We should be able to do the first QKD. So I don't know if the audience knows this, but there is only one QKD satellite in orbit right now, and it's Jinan-1 from the Chinese Academy and commercialized via Quantum C-Tech. And so for lots of reasons, we haven't connected to them yet. Small technical incompatibility, and then lack of interest from customers, I guess. But there will be several QKD satellites launching in the next year or so. I really believe that next year we'll see a few of these satellites launched. They never launch early, right? They're always delayed. In aerospace, they call it an NET date, no earlier than, right? And so these no earlier than dates just keep on creeping away, right? But I think next year we should see a satellite out of Spectral, and I think there's a Honeywell satellite projected to launch maybe the end of next year, something like that. And DLR actually launched a kind of test platform satellite that can't do QKD, but can at least send qubits, right? So there's opportunities in this space coming up very soon. So I hope that if we have this event next year, I'll be able to tell you that it all works, right? But yeah, I'm going to wrap up now. So perspectives on this. Ground networks, this is a reality. We can do this now if people have use cases, and I believe there are use cases in the maritime sector and elsewhere, right? Then this is very much a reality today, both technically and commercially, right? I'm not the only guy here selling QKD equipment, but I think there is a market for such devices, and there's a marketplace that can provide them. And I think we need to start thinking, particularly when it comes to these kind of globally delocalized industries, this satellite-based use case it's interesting and it's important, right? Like being able to connect these remote sites, there will be types of communication and types of ways in which you can provide value to these entities that require you to be able to somehow bridge these huge distances. And that's coming very soon, right? So these satellites will be available. and there is sort of interoperable infrastructure in place, being built, which will enable these kind of connections. Yeah? And so with that, I'd remind you of this. I've been told you should remind people what you showed them originally, so this is what we have here in Abu Dhabi at the moment, and I would thank you for your attention, and also the guys in my team that did most of the work. Thank you.
Thank you, James.